So this is 2009, question 1. So some of you may be wondering why I sound so tired. That's because I did too much physics last night and the day before, and I had to go out, and then I stayed out for a bit, and I only got a few hours sleep. And now here I am doing electronics. Yay, VCE, party time. But yeah, take your breaks. That's my message. Don't study too hard. But make sure you get sleep as well. Don't be stupid like me. Okay, what is the potential difference voltage across R2? R2. We have 30 ohms here, 10 volts. How are we going to do this? Voltage divider formula. Clear, we want a voltage. It's in a whatever series, and we know the total resistance. So, as I said on my cheat sheet, voltage divider formula is R on R total times V in equals V out. R on R total equals times V in equals V out. R 30, that's what we want. Total 70, because they're in series. V in 10 volts. Coming out, calculator. Calculator me. Four point three. What is the power dissipated in R1? Okay, so we wanted the power dissipated in R1. We can try and figure out, all we need is any two of these. Which ones do we have? Well, we have the resistance already. And I know the voltage drop across here is 4.3. So I'm just going to go and say that's 5.7. Because, that's 10 minus 4.3. That must be what's left over, 5.7. That was the easiest one for me to figure out. So now we use a formula. I believe it's V squared on R for power. Power equals V squared on R. Okay. Looks like I'm running out of battery. 10 minus answer gives us that 5.7. V squared is that divided by resistance of 40. Power dissipated is 0.8 watts. Okay, adds another resistor. What is the current through ammeter A now? So you look at this, and it's like, what does that actually do? I don't really understand. It's hard to tell what that actually does in parallel circuits. So sometimes it's easy if you're trying to find current just to replace that with a new resistor, like a new total resistance. So let's figure out what that is in a second. Okay, so this one will be 1 on 40 plus 1 on 20 to the minus 1. As stated by our resistance in parallel, because in parallel. See, 1 on 40 plus 1 on 20 to the minus 1. And that equals 3 on 40 to the minus 1 is 40 on 3, which equals 13.3. Okay. Now that we have the voltage, the resistance, it's much easier. Remember, current equals voltage divided by resistance. Here we're looking at the whole system. We know the 10 volts is used up over the whole thing, so we need to take the whole resistance. 10 divided by the sum of that, 43.3 equals, using my calculator, current is 0.23, or we round it to 0.2. Awesome. Awesome.